How long will it take for 500 milligrams of a sample of radium-225, which has a half-life of about 15 days, to decay to 40 milligrams? So to answer this type of problem, half-life problems, nuclear decay problems, we will use this formula. So ln of A is equal to ln of A sub 0 minus KT. Okay, now A here is the final amount or the remaining amount. A sub 0 is the initial amount. K is the rate constant and T is the time. Now in this problem, it says here, how long will it take? So the question is asking for the time or T. So we need to rearrange the equation for us to get the time. So what you can do here is you can transfer ln A sub 0 to the left side. And of course, if you transfer a variable to the left side, it will take the opposite sign. So now it becomes ln of A minus ln of A naught or A sub 0. On the right side, you're left with negative KT. Now we only want T or time, so what you do is you divide both sides of the equation by negative K. So negative K cancels on the right side. So on the right side, we have T. On the left side, we have ln of A minus ln of A sub 0 divided by negative K. Now, since we have the formula for time, we can now substitute the values. Okay, so let's start with the numerator. So we have ln of A. So I said a while ago, A is the final amount or the remaining amount. In this problem, we're given 40 milligrams as our final amount. So that's ln of 40 minus A sub 0 is the initial amount. So in the problem, our initial amount is 500 milligrams. So that's ln of 500 divided by negative K. So in the problem, we are not given the rate constant or K, but we are given the half-life, which is 15 days. And if you still don't know, you can compute K if you are given the half-life. So how do we compute K if we're given the half-life? Remember that K is equal to ln of 2 divided by the half-life. So the symbol for half-life is T1/2. So in the problem, our half-life is 15 days. So that's ln 2 divided by 15 days. So if you solve it in your calculator, ln of 2 divided by 15, that is approximately 0.0462. Okay, so that is K. So you put that in the denominator, negative 0.0462. Now, all you have to do is to compute for the time. So that's ln of 40 minus ln of 500 divided by negative 0.0462, and that will give you approximately 54.7 if you round it up. And what will be the unit for time? So you've based it on the half-life. The half-life given is in days, so your answer must be 54.7 days. And this is the answer to the question.